Hello guys, welcome back to 6.4. We're going to start with a slightly different method of division. This is called partial quotients division. This is one of the easiest methods, probably a method you will use quite a bit going forward this unit. We're going to start with this problem. I'm going to read it a couple times for you. Just like normal, I want you to look through the problem as I read it, and as you look at it and figure out what information you need from the problem. Here we go. Bina needs 72 muffins for a party. The muffins are sold in boxes of 4. How many boxes does she need? I'll read it one more time. Bina needs 72 muffins for a party. The muffins are sold in boxes of 4. How many boxes does she need? Alright, so the first step we need to do is to figure out what information is important. So, let's start with the obvious. It says she needs 72 muffins, so why don't we write that? Needs 72, I'm going to put M-U-F for muffins. Okay? And we also need, we know there's 4 muffins per box. Okay? I'm sure most of you figured out then that our math needs to be something along that, division or multiplication, to solve for, I'll just write B for boxes, okay? So I could either do 72 divided by 4 equals B for boxes. Or I could do 4 times B for boxes equals 72. If you guys are like me, you probably don't know what 4 times what number equals 72. So we're going to have a different method for it. Okay? So pause right now if you don't have this information. I'm going to erase it, and then we're going to go on and do a quick estimate so we get an idea of what our answer should be close to. Alright, so we know what our problem is. What we need to work on now is let's do a quick estimate to see what our answer should be close to. So we had 72, okay, and we had 4 is our two numbers. We knew 72 divided by 4, obviously we'd never do division like this, but we're just going to write that. Now, because I want to make my estimate be something that's easy, I'm going to do an estimate for a number that's kind of close that I know I can make an easy number with. So I'm just going to round this up to 80. And I'm going to leave this at 4. And the reason why I did that is just so I can get a close number that's really easy for me to do. So 80 divided by 4, 8 divided by 4 is 2 with a 0. So I know my answer should be somewhere in the range of 20. Alright, so now we are going to proceed to go forward with partial quotients division. If you need to, please pause your video now and write this down because I'm about to erase this. Alright, so let's begin. So to start with, you write division, your division problem, exactly like you would have in the past when you were just starting out. So 72 divided by 4. But to figure this out, then the next thing we're going to do is we're going to take a line on the right side and we're going to draw it straight down here. The reason why I'm doing this is to separate my partial quotients from the math I'm doing when I do a normal method of doing division. Okay? So now I start thinking, how many 4s are in 70? Okay? Normally you would write the number on top and you would work your math that way. If I think of my multiples, let's just start with big ones. 10 times 4 is going to be 40. 20 times 4 is going to be 80. That's going to be too much. So I'm going to start with 10. Okay? So I write 10 here. It doesn't matter. You could start with 2 if that's the only multiplication fact you knew times 4. As long as the product, when you do 4 times the number I wrote here, is less than 70, it doesn't, or 72 in this case, it doesn't matter. If it's less than the dividend, we're okay. So I did 4 times 10. So 4 times 10 And the answer to that is 40. So I write that there, draw a line. Now I just need to subtract this. 2 minus 0 is 2. 7 minus 4 is 3. Now I go on. How many 4s are in 32? Some of you may know the answer to this. Some of you guys are amazing at your multiplication. But pretend I didn't. Pretend I don't know my multiplication facts very much. But I do know my 5 facts, right? 5, 10, 15, 20. 20, well, I get a, well, 4 of them is 20, so we're going to stop there. Otherwise, it would be counted by 4. So 4, 8, 12, 16, 20. I'm just going to stop at 5 times 4 right now because I know 5 times 4 very easily. So I go 20 here. Okay, so I did 5 times 4. Okay, so the number, you see the number that I'm writing here on the side in my partial quotients column? I'm always timesing that by the divisor, the 4 up above. All right, now let's do some more subtraction. 2 minus 0 is 2, 3 minus 2 is 1, and I'm at 12. Now, I know a number I can times by 4 to make 12, and that number is 3. Okay? If I didn't, I could even do 1 4 at a time, or 2 times 4 is 8. It doesn't matter, as long as at the end you add up all of the numbers in the partial quotient column, you're going to be okay. So now I'm doing 3 times 4. That gets me 12. I'm going to do some subtraction. 2 minus 2 is 0. 1 minus 1 is 0. Now, the answer I have here is less than 4, so I stop. Now I need to add up these numbers. 10 plus 5 is 15. Plus 13 is 18. Okay? 10 plus 5, 15, 16, 17, 18. There's my answer. So the answer to my division problem is 18. Okay, so if we look at that answer, Bina needed 18 boxes, and compared to our estimate of 20, we were pretty good. 20 and 18, very close numbers, so I think I trust my math. But I'm going to show you that I can do that same math problem, the 72 divided by 4, with very different math, with very different numbers dividing by, and get the right answer. Let's say I only knew that 5 times 4 was 20. Say that was the only number times 4 I knew that was less than 72, my answer. Okay, I probably could have done, 100 times 4 is 400, but pretend 5 was my number. So then I would just do 5 times 4, 20, subtract those. 2 minus 0 is 2, 7 minus 2 is 5. Okay? So I can do another one. Let's do another 5. 5 times 4. Okay, 20 here. Subtract it. 2. 2 minus 0 is 2. 5 minus 2 is 30. Oh, let's do another one. 5 times 4. 20. Okay. Pretend I didn't even know that 3 times 4 was 12. So let's just do 2 here. 2 times 4, we'll do 8. 12 minus 8 is 4. Sorry, my math there is overlapping. And then I'm left with 4 left here. I can do one more. 1 times 4, I get a 4 here, and get a 0. Then I just add these numbers up again. 5 plus 5 is 10, plus 5 is 15, plus 2 is 17, plus 1 is 18. Okay, so my answer is 18. So it just shows that it doesn't matter what numbers you know, even if you're not amazing at multiplication. You can use the smaller numbers that you know, the multiplication facts you do know, to solve the problem just as easily.